Hi there, it's me Sanjay. Welcome to Pantech Solutions, and I'm warmly welcome you all for the series Deep Learning Masterclass. So in this session, we are going to work on a project like object recognition. Okay, so here we are using MobileNet SSD to recognize the object in a real time. So here we are going to use the camera to recognize some of the object which is present in front of the camera. Okay, so I hope you guys are excited to attend the session. So if you are excited, you just put "I'm excited" in your live chat. So before going on to the session, let us welcome each and every people. So first of all, good evening, Sanjeeva Shruti, who mentioned my name. Good evening, and Kamis Khegazi sir, hi sir. It's really great that you are connecting again. So and Deepika, hi, good evening, and Nitya Perezami. Okay, so your questions I'll note down. Okay, don't worry. Okay, and Srishti Jain, hi, good evening, and Nandini, hi, good evening, and Saroj Singh, ma'am, hi, good evening, and Manjeet Singh, good evening, Aditya Chaudhary, good evening, and Harshra Chauda, hi, and Mahat Kalik, good evening, and Neelam Srinivastava, good evening, and Shaishwari, good evening, and Aparna, hi, good evening, and Mercy, hi. So hello guys, and Deepish Gupta, hi, good evening. So hello guys, I hope you guys are doing good, right? So before going on to the session, same as like there is an announcement. So attendance link will be available around 4:30 p.m. So once the session is completed, start filling up the attendance form. So it's really great that you have attended like a free webinar. But if you are paid for a certain webinar, definitely you will attend. But other than that, if you are still if you are still just staying this much times or like for 3 days continuously for learning which is provided for free, it's really great to connect with you people who are really eager and hungry to learn. So I really feel happy. So thank you so much for having your presence on fourth day of the session. So I hope you guys all got your source code. Like yesterday's source code we are sent as an email. I think today's morning, I think the mail have been sent. So if you got the source code of the yesterday session, you just put I got the source code. It's really nice. Like you just create that white in your live chat. Okay. So here we are going to work on like object recognition. So in this figure, so on the figure there is like a dog, and then bicycle is here, and tree, and then car is here. So in the images or in the picture which is shown here. Okay. So out of it, object recognition in the sense we are going to detect the object. Okay, so like in the classification parts we have seen some more concepts like binary classification and multi-label classification, multi-class classification, like that we have seen some more types, right? So here it is like multi-label classification. So for an example, like multi-label and multi-class is there. So for example, if there is a certain frame, so on that frame, if it want to recognize multiple objects, okay, so that's what we are which we are going to do it now. Okay, so thank you so much that a lot of people have posted that I got source code, I got source code. Thank you so much for your response, guys. Okay, so yeah, so here we are going to deploy the same thing. Okay, we are going to recognize like multiple object which is present in a certain frame. So for example, I'm here. So it should be recognized as a me, like person, right? And then chair is here, so it should be recognized as a chair. And water bottle is here, so water bottle should recognize as a water bottle. So likewise, whatever the things in the certain frame you just want to be recognized. Okay. So and so that's the one concept. Other than that, there is also a second main factor. It is needed to draw the bounding box. So bounding box in the sense you just want to track where the object is by drawing the bounding box. For example, if I'm sitting here like this, so you just want to detect me in the complete frame, and after that you just want to locate where I am. Okay, so like you just want to draw the bounding box around my body in the frame, and whenever I'm moving, that bounding box should also move. Okay, so that's the main challenge while going for object recognition applications. Okay, so I hope you guys are clear about object recognition. So it may be like any object, guys. So there are like different models and those things. We are going to explore each and everything in the upcoming slides. So before that, object recognition, it is like a kind of vision for a robot. Okay, so like as like an Indian movie. So that Dr. Bora will ask like ask that robot to pick up a gun. So instead of picking up a gun, it will picking up the bun, right? So that two objects, so that is like misclassification, right? So it can't able to identify. So it may be problem with some kind of sound system, like voice based is the voice based. That is maybe the problem, or else it may be problem with the vision. So it can't able to recognize what is bun and what is the gun. Okay, so that may be the issue. Okay, so these two are all the possible of issues. Okay, so something like that. So by using lot different variety of models, we can able to develop this object recognition by ourselves. Okay, so it is not required for like industrial project and those things. You can also develop like this. Okay, so I hope you guys all got this. And while talking about the implementation of object recognition, so here we are segregated as like a three ways. Okay, so the first one, by using a pre-trained model. So what is mean by pre-trained model, guys? I think in the face recognition application, we have used one HAR cascade, like in the face detection, we have seen like some HAR cascade frontal facial algorithm. That is like .xml file, which is used to detect face. Like same as like the car, so which we have used to detect a car. So we have used one file that is like machine learning classifier. Okay, right? So cars.xml file. So same as like while talking about the deep learning also, there is also a methodology, like there is also a model which is already been trained for. Because guys, I hope you guys all know the difference between the CPU and then GPU. So you just put your answers in the live chat, guys. Okay, what is the difference between the CPU and the GPU? So let us have this object recognition application. So and as we have discussed before, so what are all the challenges in the deep learning? So first of all, this deep learning, the positive thing on the deep learning is here we need not to specify each and every feature, right? So it is going to automatically extract the features. So it is the benefits. While talking about the another aspects, we need to provide huge number of data when compared to the machine learning, right? So for example, if you want to recognize two objects, like for example like mobile phone versus the keyboard, so if that is the application, we need to provide a lot of images to have the better classification. Like for example, guys, like if there is a mobile phone like this, okay, if this system want to recognize this mobile phone, I just want to take this image in a different wide variety of ways. So like portrait, landscape, and tilted angle, and grounded angle, and with a different background. So there are a lot of ways, lot of angles we just want to collect the database. There is also a inbuilt method can be useful for doing that stuff. But other than that, we need to collect a lot of images by having a good lighting, backlighting, different angles. So that we need to provide huge number of data, guys. So for having a better classification. So that's one part. Okay, we need to collect lot of data set. Okay, so yeah, we are getting the response. That is CPU is limited to system, CPU control unit, GPU means graphical unit. Okay, okay. So normally CPU, I hope you guys all know, central processing unit, and GPU means graphical processing unit. So why I'm talking about this? Because as we have already discussed, we need to provide large number of data to the deep learning for the training process, right? So for doing a training, we need a high computational power, guys, because for example, so for 28 years you have seen lot of objects, right? So if you want to suddenly give your intelligence, so normally AI, so we are going to transfer our intelligence, our like our experience in the format of data. So in front of you, you have your artificial intelligence baby. So you have a lot of knowledge, right? So not a lot of knowledge on based on like objects. So if you want to provide that huge knowledge into a machine or a computer within a short span of time, we can't able to provide without the high computational systems. Okay, so now we guys all using normal CPUs, right? So normal Intel processor and those things, and somebody may have GPU system, GPU cards, and other than that. So and same as like we need that kind of graphical processing unit to handle that much of images. So for example, guys, so let us take the same object. So like I'll take apple and then banana. So if I want to classify apple and then banana, I need to provide a lot of images. I think you guys all know. So 1000 images of apple, 1000 images of banana. Let us take for an example. Okay. So or else you can take like 5000, 5000. So 5000 images of apple, which includes green apple, red apple, half cutted apple, four cutted apple. Okay. Likewise, we have collected a lot of images. So totally we have like 5000 images of apple and 5000 images of banana, like different colors and those things. Okay. So now totally we have 10,000 images, right? So for an example, if you are training that 10,000 images in your normal laptop, okay, so normal we used to have nowadays, right? So in a normal like i3 processor or i5 processor, like only a 4 GB RAM. So if you are doing that training process in your normal system, it may take a week or days. Okay, so like it may take like a week, okay, to complete the training process. So just for an example, guys. So totally we have 10,000 images. If I want to train that 10,000 images in my laptop, definitely it may take like 1 week. Okay, so 1 week I just want to wait for my system. It should not be turned off. I just need to check out the power, right? So likewise, there are a lot of challenges. Okay, so challenges to handle the computational power. So there is a way to overcome that kind of scenario, which is we can go for the GPU, graphical processing unit. So where Nvidia nowadays they are playing a major role in artificial intelligence because before we have already used the AMD graphics card, right? But other than that, Nvidia is more popular for graphics, handling the high graphics games and those things. And how many of you playing like high graphics games? You just put your answers in the live chat. Okay. So yeah, so a lot of people are using like a high graphic. A lot of people are used to play high graphics games by using the graphics cards. Same as like nowadays, artificial intelligence solutions are also provided by Nvidia. They are making a lot of boards which will be useful for doing that kind of high computational power based like activities. Okay, so this is the thing, guys. So we need high computational system to train a huge amount of data set. So based on it, here we can able to implement object recognition based on three main ways. Number one, pre-trained model. So this will avoid that problem. So we don't need to collect each and every database. So for example, if your application need to detect a person, you can go for the pre-trained model because there are a lot of pre-trained model which is used to detect a lot of objects like keyboard or TV monitor and and then laptops and so likewise. So like it can be useful for detecting lot of objects which is already been trained by using high-end GPU systems. Okay. So you can simply import that model and you can work on like you can able to deploy it in your real time. Okay, so that's what we are going to do in this session, pre-trained model. Okay, we are getting lot of me. It's really great. Okay, so then we are using like we can go for the transfer learning concept. So what does mean by transfer learning? So transfer learning is nothing but guys. So pre-trained model. So we are going to take our pre-trained model. I hope you guys all remember from the yesterday session like weights and those things, right? So on the yesterday session itself, we have saved the weights file separately, right? So what we can do is what is mean by transfer learning is we can load the pre-trained model. Okay, so you are going to load the pre-trained model, that architecture which is already been trained, which already has that knowledge and those things. Okay, so we can import that pre-trained model and on the output layer. So there is the output layer, right? So we can able to remove that output layer and we can able to replace that with the our custom database network. Okay, so I hope you guys all understand. So we are going to load the pre-trained model, which is already having that knowledge, like which has been trained for a lot more objects, because that model which already seen a lot of things. It is not a newborn baby. Instead, it is like 10 to 12 age kid. Okay, because not a 12, so you can take like a 20 itself. Okay, 20 age kid. So who is having some more knowledge about objects. Okay. So that some more knowledge which is already present in that model. So we can able to load that model and we can able to remove that weights, like remove the sorry, not a weight. We can able to remove the final output layer and we can use the previous weights of the pre-trained model for our own custom data set. For an example, if I want to recognize same like mouse or keyboard, so for my mouse, so it is going to be completely different. So likewise, if I'm going to use that, we can able to use that pre-trained model to train for my custom database. Okay, so that is known as a transfer learning concept. Okay, so I hope you guys are clear. So third method is building it from the scratch. Building it from the scratch in the sense, we need to, from the yesterday session, we have started with the sequential, right? So model is equal to sequential and this layer, this layer, this layer. So likewise, we need to add the layer and we need to train it. So definitely we won't get much accuracy. So definitely we need to tune the hyperparameters, like tuning in the sense changing neural network design, adding the layers, and whenever we are facing underfitting and overfitting problem, we need to find out the solution. So we just want to include that, and we can able to increase the data set size, and we can able to increase the data set clear data set, and we can able to tune other parameters such as like batch, epoch, and each and everything we can able to change. So we just want to tune it by identifying whatever the problem which is. So based on that, we'll get a model which is working perfectly for our current data set. Okay, so I hope you guys are clear what are the three methods. Pre-trained model, which is the model which is already been trained for certain only certain objects. Okay, we can use the certain model to detect only that object which is already been trained for. And transfer learning, which is used like it is going to use the pre-trained model weights, but we are going to replace the output layer with our custom layer, okay, which is for custom our data set. And third thing, that is building it from the scratch, which means we are going to start it from the scratch. We are going to start designing a neural network, and we'll observe the output, and we're just going to tune it again to get the better accuracy. So likewise, these are all the three major ways. So I hope you guys are clear. So if you are clear, you just put I'm clear in your live chat. Okay, so these are the three things on that we are going to see the first method, that is a pre-trained model. Okay, so here I hope you guys all know about the deep neural network, right? So here we have input layer, and whenever there is a multiple hidden layers, which is known as a deep neural network, which can also be called as a deep neural network. Okay, so why we are going for multiple hidden layers? Whenever there is some kind of complexity, okay, complexity in your classification or any algorithm, there we need to go for the deep neural network, where it can able to identify the complex. It can able to extract very complex features. Okay, so thank you so much that Nivi, Elizabeth, and Ayushi, and Srishti, Sai Kumar. Thank you so much, guys, that you have posted that you are clear. Okay. Yeah, that's it. So here we have the neural network, which is very deep neural network, which means it is having a more number of hidden layers to extract more number of features. Okay, so for example, if I have 10 objects, so 10 objects in the sense, so thank you so much, Sudhakar, who posted, I am very clear, and super clear by Selvanagi. Thank you so much. So here we have lot of objects, guys. So I have mouse, I have keyboard, there are a lot of objects. So each and every object, it is having different kind of features, like in the shape or color, it may be anything. Okay, while talking about the fruit, you can able to include color as a feature, but while talking about the object like this, like keyboard or water bottle or something like that, we can't able to consider color as a feature, because there are there may be any color. Okay, right? So here there are a lot of understanding should be happened based on like our network. Okay, so that's why here we can able to use for like, we can go for like deep neural network, where complex data can be handled with the help of DNN. Okay, so that's it about here. And here we have speed comparison on image classification. So these are like frameworks, guys. Cafe, Keras, OpenCV, PyTorch. So here Cafe, which is really speed. Okay, so it is really speed by processing the frames. Okay, so for example, guys, I'll tell you another thing. So I think some people may hear about the YOLO. YOLO means you only look once. So which is also useful for recognizing the object. We can go for it by using the Coco data set. So if you are going for the YOLO object recognition, so that is really heavy, guys, because there it has been trained for more than like 20 plus 30 plus objects. Okay, it is like it can able to recognize even a spoon. Okay, it is really great one. But while talking about when compared with the Cafe trained model as well as the YOLO trained model, YOLO is too heavy, and whenever you are trying to run it in your laptop, you may feel or like you may see a little bit of hang, and your laptop may be little bit frozen. The frame switching, it will be little bit slow. For example, I hope you guys have been watched the Nokia 010 mobile phones, right? So from the video, so if you turn on the video in your Nokia 010, like keypad mobile, like whenever there is a camera, so some of the mobile, I forgot the model number. Okay, so you just so on the old mobile phones, if you are turning the video camera on, and if you are moving from here to here, okay, so I'm just moving, I turned on the video camera here, and I'm just moving here to here. If you are observing it in a display, it will take less than a second, like it will take like a second to have the difference between in the frame. Have you noticed, guys? If you notice, you just put I noticed in your live chat. So it will have lot of lag on frames. So that is known as FPS, frames per second, right? So that now what we are using, we are going for time lapse, and we are recording a slow motion. So there are a lot of benefits now we have. right? So that is the FPS. So that FPS, it is going to be very less on old mobile phone. Same as like that FPS, if you are using normal PC, there you will experience very less FPS. Okay, so like sorry, like it will be like a very less FPS, right? So very less FPS means you will see lot of delay. So for example, in the camera, if you are showing like this, so it will take a lot of time to show it in your window. Okay, so that's a difference, major difference. So that's what that speed which he had mentioned us. Okay, so time taken in MS. So here, by observing this cafe, which is really performing well on when compared to the like when seeing about the speed. Okay. So and then a pre-trained model for object recognition, there are like a mobile net SSD, Google Net, SpeedNet, faster RNN, ResNet, Inception, YOLO, VGGNet, and etc. So on the right side, you are seeing lot of things, right? So lot of dots are here. So that dots are nothing but it is a models, guys. Okay. So like VGG11, VGG13, VGG16, VGG19, NASA net, a large network which is having more top accuracy. So likewise here we have lot of models which is being plotted. So each and every dot is a model. Okay. So like ResNet 18, so which is graph like based on like operation like that model with that top accuracy. Okay, so that's what which is being here. Okay, so I hope you guys got this. These are like list of model which we can use it for object recognition. Okay, so here we are going to use mobile net SSD, that is a single shot multi-box detector. So on the previous image, so I hope you guys have been watched that image. So in this image, if you are seeing this image, there is a dog, right? So this is the picture. So let us take this is the same picture. So on that same picture, so it is not, it is just drawn like a matrix. So like I hope you guys we have already seen about what is meant by matrix and those things, right? So it have this matrix, right? So matrix means so it will have individual cells. So from this complete individual cells, so here it is drawn some bounding box, right? So there it is drawn multiple bounding box around like each and every part of the frame. So from that it will try to locate where the object exactly is. Okay, so that other than that other boxes will be removed and finally you will get the output like this. So that's what that process will do. Okay, so this mobile net SSD. Okay, so here it will use the depth-wise convolution filters and point-wise convolutional filter to extract the features. Okay, so here we have three layers. Okay, what is the three layers, guys? Can you able to guess that? Okay, so here we have these layers. Okay, so here it is going to use a filter to recognize or to identify the object which is present in a frame. Okay, so I hope you guys got this. So this SSD, which is specially for like bounding box drawing, because there are a lot of things, guys. So if you want to recognize the image or object, so for example, like if you want to recognize the leaf disease detection, so leaf can be detected, like leaf disease can be detected easily. So on the window itself, it can able to give you like this is the anthracnose disease, this is the late blight disease, like that it can give. But other than that, there is a next level approach where you can able to locate the disease. Okay, so we just want to locate the disease and we need to get the coordinate of the disease in a leaf and we can able to draw the bounding box around it. So that's what this SSD is specially for. Okay, by using this mobile net SSD, we are not only going to recognize the object, we are also going to locate the object which is present in a certain frame. So for example, if there is a certain frame, I'm just showing a mobile phone and I'm just showing this keyboard. So in this frame, if it is giving the output on that frame, there is a keyboard, there is a mobile phone, there is a person. So instead of giving like that, if our model is can able to draw the bounding box like this. So bounding box around the mobile phone to represent this is the mobile phone. Bounding box around me to represent me as a person. To bounding box around the keyboard to represent this the keyboard. So likewise, if it can able to draw the bounding box, it is the next level approach. Okay, so that's what it is going to be done with the help of this mobile net. So here we are seeing this mobile net SSD architecture. It is really great, right? So there are a lot of convolution layers. Like it starts from 1 to it's about like 11 convolution layer. Okay, so here we have more 11, 12, 13, 14, 15, 16, 17 layers are here. So you may have multiple hidden layer which will be useful for extracting more number of features. There are a lot of even in the MATLAB, they are also working like 100 layers of neural network. Just imagine, guys, 100 layers of neural network. How many features it can able to extract? right? So there are a lot of other tuning parameters also there. Okay, so with the help of that, we have lot of features can be extracted by using deep neural networks. Okay, so first of all, you have the input layer, and another main thing I wish to say, guys, here in this architecture on that input layer, there is the image size that is represented as the 300 cross 300 cross 3, right? So and another main thing I wish to say, so for example in this model, guys, so if we have seen a lot of models here, right? So like BG16, Inception, YOLO, faster run, and like each and every pre-trained model will have some prerequisites. Okay, as I've already told you, whenever you are applying some kind of pre-processing method for training, doing a training, same pre-processing should be done for the image which is already in the process of testing. Okay, so for example, in the cars.xml file, which we have seen before, that frame which should be converted into a grayscale, because that cars.xml, that is machine learning classifier, which is already trained by with the help of using grayscale image. Okay, so that's why I'm telling you, for each and every model, it will have some prerequisites where the input image in which format which they have been trained for. Same format we need to do the pre-process for the test images as well as the frame which is read from the camera. So for example, if they are using 300 like 24 cross 24 image, okay, only small image, 24 cross 24 cross 1, which means that is the like binary image. So if they have trained and they have prepared a model in the format, so if you are going to use the same model, and again if you are observing, or again you are just going to obtain the frame from the camera, you just again change that, or we need to resize into 24 cross 27, and again we just want to convert that color image from the camera into a grayscale or binary image, so that it will match to the pre-processing which is done for the training images. Okay, so same pre-processing should be done for the frame which is going to be read from the camera or test images. Okay, same as like here mobile net SSD, that is having a prerequisite that image should be 300 cross 300 cross 3. 3 means 3 channels. That is a color image. It is not a grayscale image. Okay, so that is a color image, and the size, the dimension of the input is 300 cross 300. Okay, so I hope you guys are clear up to now. So if you are clear up to now, you just put I'm clear, or I'm extremely clear, I'm super clear. So likewise, you just post your answers like in your live chat. Okay, so that I'll proceed further. So here we are going to use the ReLU activation function. So and on the previous session itself, we have seen a lot of activation functions, right? Like softmax and sigmoid and those things. So here ReLU also we have seen. So on the certain instance, it has been like specified as a ReLU, right? So while talking about the ReLU, so it is nothing but so it is going to get the input, guys. Okay. So whenever the input is positive, so whenever the input is negative, it will return 0. Okay, so whenever the input is positive, it will return the same number. So that's why the graph of the ReLU activation function, which is look like this. Okay, so whenever the input is 1, it will return 1. So likewise, whenever the input is some value, it will return the same value. Whereas if the input is a negative, okay, then that will return the 0. Okay, so that's what the meaning of ReLU activation function. So that's why the graph is like only this. Okay, there is no any negative point. So whenever there is a negative point as an input in the beyond this, so it will make the negative point into a 0 line. Okay, so even though it is getting like what, like -1 or -2 or -3. Okay, so it will make that -1 or -2 or -3 to go into like 0th condition. Okay, so that's why I'm telling you this ReLU function. Whenever the input is negative, then it will make it to 0. Whenever the input is like positive, then it will return the same value. Okay, so yeah, we're getting response that explain once again. Okay, so I'll explain once again. So from where I don't know. Okay, so here we are using the pre-trained model for object recognition. Pre-trained model is which they have used a lot of high-end CPUs or high-end GPUs for training a lot of objects. Okay, so out of it, here we are going to use the mobile net SSD, that is the single shot multi-box detector, which is specially for drawing the bounding box around the object. So for example, I'm just showing here. So from this frame, if it can able to draw the bounding box around me, so to recognize me as a person, and it is just going to draw the bounding box around this mobile phone to recognize this is the mobile. So likewise, that is specially for drawing the bounding box around the object. So out of it, there was also a YOLO, that is you only look once. That is like another model. Okay, so that when compared to this mobile net SSD and then YOLO, so YOLO is really too heavy because that has been trained for a lot of objects by using the Coco data set. Whereas this mobile net SSD, okay, it is like it is not that much heavy like YOLO. Okay, so here it is going to use the filters like depth-wise convolutional filter and point-wise convolutional filter. I hope you guys all know about the convolution layers. What is the function of it, right? So here it's going to use this kind of filter to extract the features. Okay. So while talking about this architecture, in this architecture, it will have more number of hidden layers. Okay. So more number of hidden layers in the sense it is going to extract more number of features. Okay, whenever you are increasing hidden layers or like more number of hidden layers, it can able to extract more number of features from your image. So for example, if you want to classify apple and then banana, if that is your project, there it doesn't require these much of hidden layers. Okay, you can able to achieve within 3 to 5 hidden layers. But here in this mobile net SSD, because this mobile net SSD which has been trained for more than like 10 objects, so that's why here the layer which is really huge, like convolution 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are a lot of hidden layers to extract lot of features because that is going to recognize the water bottle, that is going to recognize my mouse, that is going to recognize my keyboard, that is going to recognize TV monitor, that is going to recognize my like myself as like a person. So likewise, it is going to extract lot of features and it is going to locate where that specific object is. So you are visualizing me, guys, right? So here you just visualizing me. I'm just showing here. So you just see me. That is the current frame. So on that current frame, if you that our model can able to locate where a certain object is, where my mobile is there, and where the person is here. So likewise, it can able to recognize what are the features. Okay. So I hope you guys are clear now. So ReLU activation function, which is a kind of activation function which is used to activate the neurons at the next layer. Okay, so here whenever the input is negative, then that will change the value to the 0. Okay, whenever the input is positive value, then it will return the same value. Okay, that's what ReLU short form. Okay, so if you have notes, you just take your notes. Okay, so there is also a leaky ReLU function which will partially release the negative value. Okay, that we'll see on the other session. Okay. So ReLU, you just imagine that you just have your that concept. Mainly, whenever the input value is negative, it will change into 0. Whenever the input is positive, it will going to return the same positive value. Okay, that's what here ReLU is. Okay, so I hope you guys are clear now. Okay, if you are clear now, you just put "I'm clear now" in your live chat. Okay, so yeah. So up to now we have done the basic concept, right? So what we are going to do, there are 3 methods: pre-trained model, transfer learning, and then building it from the scratch. Out of it, we are going to choose the pre-trained model. So on the pre-trained model, there are a lot of models which is present like YOLO, mobile net SSD. There are a lot of models which is available like ImageNet and etc. So out of it, we are going to use mobile net SSD, single shot multi-box detector. So with the help of that, we can also not only we can able to recognize the object, we are also going to locate where the certain object is. Okay, so like there is a difference, guys. So for example, if I'm showing here, if I'm just showing like this, if our model is giving in that frame, there is a mobile, there is a person. So instead of giving like that, if our model can able to draw the bounding box, it can able to locate whenever I am moving like this, that bounding box will also move like that. Okay, so that bounding box will also move like that, and it is going to track each and every object. So that is the next level approach. That is a multi-box, like drawing the bounding box around the frame. So this is what which we have seen. And another main thing is to extract the more number of features. We are using lot of hidden layers which is present in that mobile net SSD architecture. Okay, so that is a pre-trained. Even though that is a pre-trained model, we just explore that architecture. That it has more number of hidden layers because why it is having more number of hidden layers, because it need to have to extract a lot of features, because here we are going to classify more than 10 objects, so that it is needed to have more number of hidden layers to extract more number of features. Okay, so that's the purpose of it. Okay, so I hope you guys are clear. Thank you so much that you have posted. I'm clear. Okay, so that's it. And now it's time to learn the programming syntax. So I hope you guys all know about the computer vision, right? So yesterday we have before we have seen like hands-on experience, like working like computer vision, how to read the frame from the camera. So those things we have seen. Same as like here we are going to learn another things, guys. So another main thing I told you before, each and every model will have some prerequisites. So for example, mobile net SSD means, so it is having prerequisites that image should be in the 300 and 300 cross 300 size or shape, and it should be in the color image. So likewise, each and every model will have the prerequisites. So we just want to observe the model in which basis it has been trained, in which data set, size and then color format, how it is being trained. Same thing should be done for our deployment stage also. So whenever we are reading the frame from the camera, we need to deploy the same pre-processing technique which is they have been used for training the data set. Okay, so the pre-processing technique which is used for training the images should be useful, should be used for the testing images also. Okay, so that's why then only we can able to get that the accuracy which we want. So here, deep neural network. Here we are going to convert the image into blob image. Why we are going to do that is because this mobile net SSD is having prerequisites that they have converted an image into a blob image. Okay, I'll show how the blob image will look. So this is the syntax. CV2.dnn. DNN means deep neural network dot blob from image. Okay, so blob from image. So with the help of this syntax, we are going to convert the normal image into a blob image. Okay, and so whenever we are going to use the pre-trained model, we are going to use that pre-trained. We are going to load that pre-trained model into my single variable. Okay, so to load that pre-trained model, so we can able to use this DNN, that like cv2.dnn.create cafe importer. cv2.dnn create TensorFlow importer, cv2.dnn.read net from cafe. So here are the main thing. So cv2.dnn. So cv2 computer vision we know, DNN deep neural network we know. So inside that cv2 we have imported like DNN. So inside that we are going to use read net from cafe, which means we are going to import the pre-trained model which used the framework called cafe. And if you are going to use the pre-trained model which is already been trained with the help of TensorFlow, means we can load it with the help of cv2.dnn.read net from TensorFlow. If the pre-trained model which is already been trained by using the framework called the Torch, means we can use that, we can able to import with the help of cv2.dnn.read net from Torch. Okay, so likewise, based on the framework, we need to specify the framework. So this syntax to import the library. So mobile net SSD, that object recognition which we are going to do it today, that object recognition which uses the framework called cafe. So what is the syntax here which we are going to use? So you just put your answers in the live chat. Okay, so here these are the main syntax, the loading image from the disk to DNN. So what is mean by that? Here we are going to use that image. Okay, so we are going to take that image. Okay, so that's what, like, to convert that into a blob. Okay, so and then second part, so here importing model from various framework, because there are a lot of models which has been trained for different frameworks like F8, TensorFlow, Torch, and etc. So if you want to load that certain pre-trained model, we need to specify that framework by using the syntax called cv2.dnn.readnet from cafe, which means it is going to useful for importing the model which using the cafe framework. And if we are using readnet from TensorFlow, means it will be useful for reading the model with the help of, like, which is the TensorFlow framework. Okay, so I hope you guys are clear up to now. So if you are clear, you just put a clear in the live chat. And finally, the dot forward method, which will be useful for doing a classification. On the previous method, we have used like fit model.fit and those things, right? So same as like whenever we are going for the DNN, we can use the dot forward method. So dot forward method means it is going to give you the classification results. So classification results in the sense, first of all, it will give what class it is. Okay, so it will have the some array where it has been already trained for, like a background, dog, cat, and likewise it will have that certain array. So it will give you the class ID first. Okay, so class ID will it is going to give us the if it is the 0 means that is a background, if it is 1 means that is a dog. So likewise it is going to return the class ID, and second it is going to return as the accuracy. Okay, so that dog, which is recognized as the 98% accuracy. So likewise, it is going to give us the accuracy. Okay, and then it is going to give us the coordinates of the bounding box. So on the certain frame where that object or where that object is located at the frame, that bounding box, so that we can able to draw the bounding box around that object. So these are all the coordinates which we all obtain from this forward function, dot forward function. Okay, so thank you, Sanjeeva Shruti, Swikriti Raj, and Rahul, Raj Aryan. Thank you so much, guys. Okay, so here we have a blob image. So this is what the blob image look like. Okay, so here this is the normal image, and this is the blob image. So the pre-processing technique, which ImageNet, like MobileNet SSD, they have been used for like to convert a normal image into a blob image. Okay, so to convert a color image into a blob image, here there is the syntax cv2.dnn.blob from image of the resized image. Definitely we need to do the resizing also, like converting into 300 cross 300 and like color, like RGB color image. And after that, we are going to apply, we are going to convert that resized image into the blob image, because our model is having some prerequisites that our image should be in the blob image. So we need to convert into a normal image into a blob image. So for that, we have read that image, and then we have specified the scaling factor. So this is the scaling factor which we have used. Okay, and then spatial size. So spatial size, which is the dimension of our model, which it is going to took out. So for that 300, 300 and 127.5. So this is the mean subtraction value. So this is the values, constant value, which is really working good for pre-trained model, for especially ImageNet SSD. Here it is not required to do any changes, guys, because these are like values which already been configured, where you can able to observe the clear output. Okay, so it is not required to change any scaling factor. Here we are not going to tune anything. Okay, so we are going to directly deploy. We are going to load our model, same pre-process technique which we are going to use it for the frame read from the camera, and we are going to recognize what are the object which is present in the frame. Okay, so I hope you guys are clear. So let us before going on to the program, so let us have the final overview. So first of all, what is the workflow of this project? Okay, so first of all, we need to load the model, of course, right? So what model we are going to use? The same model we need to download, and we just want to load the model into a certain variable. Okay, so certain variable in the sense which we have loaded with the help of this one, right? So cv2.dnn.readnet from cafe. So by using that, we are going to load that model into a single variable. Okay, and then select backend. So select backend in the sense what kind of framework which we are going to use. Okay, so like which we are going to use, so that we need to specify. And then select target. So target in the sense like what it is going to detect. So likewise, we need to detect the select the target. So for example, so MobileNet SSD, it is already be trained for only specific 10 objects. Okay, so we just want to specify what are all the 10 objects in the like array. Okay, so and then we are going to read the frame from the camera, and after reading the frame from the camera, we need to convert that color image into a blob image. And after that, before that, we need to do the resizing also, like 300, 300, which is done with the by using the previous syntax. And we are going to passing the dot forward function. We are going to pass that pre-processed frame which is read from the camera into the forward function, so that that forward function will give you the results like class ID, accuracy, and then bounding box. Okay, bounding box coordinates. And finally, we are going to process it, and we are going to draw the bounding box around the current frame, and it is going to display you the output. Okay, so I hope you guys are clear, crystal clear up to now. So if you are clear, let us go for the program. Okay, just put your answers in the live chat. Okay, so are you guys clear? So are you guys clear up to here? Okay, if it is clear, you just put I'm clear in your live chat. Okay, so let us go for the program. Okay, so I hope you guys are ready. So if you are ready, you just put I'm ready in your live chat. So here we have the source code number 4. Okay, so here we have the model files, guys. Okay, so the model which we are going to use is MobileNet SSD, which has already been trained for recognizing the object. And the framework which they have been used for training that object is Cafe. Okay, that's what the model which we have. Okay, so Cafe model and prototext file. Okay, so which we have these two files. Okay, so we are going to use this model, these two model files. These two are the model files. Okay, we are going to use this model file to recognize the object. Okay, so main.py, so edit and then edit 3.7. Thank you so much, guys, that you are posted and clear in your live chat. Thank you so much. It's really great. Okay, so before that, let us try to run the program. Okay, so on that output, so here video capture of two. Okay, so Python is main.py. Okay, so if you are seeing here, it might not be looking good. Okay, so here if you are seeing this, there it is recognized as a person, colon 99.96 percentage accuracy. Okay, so now I am introducing water bottle. So if I am showing water bottle, it is also recognized like 98 percentage accuracy. Okay, so likewise, it is going to recognize each and everything. Okay, it is not recognized well. Okay, no worries. Okay, so bottle is here, and just want to recognize like display or TV monitor or something like that. Okay, yeah, it is somewhat it is recognizing. Okay, okay, it is not good. Okay, so no worries. So likewise, we can be able to recognize multiple objects. Okay, so here we have it is recognized as a person as well as a bottle. So it is not only recognizing me. Okay, so it is also locating me. It is already tracking me, like it is drawing the bounding box around the object, and I just shown in the display. Okay, so that's what which we are going to work on. Okay, so I hope you guys got this up to output. So if you are clear about the output, so we just put I'm clear in your live chat, so that we'll proceed. So that if you know the output, no, so definitely it will be very easy for you guys to understand the program. Okay, so that's what that's why I just shown the output first. Okay, so if you are clear, you just put I'm clear in your live chat. So let us write the program, guys. It's very simple. Okay, so I hope you guys are ready. So if you are ready, just put I'm ready in your live chat. Okay, so here we have the source code. So let us explore. So I'll just expand the window. Okay, so I think now it is visible for you guys. Okay, so here, first of all, we have imported a library called NumPy. Okay, so NumPy as NP. Okay, so which is useful for handling the arrays. Okay, so you just like take your notes like array or matrix multiplication. So I think we have already discussed about the like libraries, right? So that's what which we are did here. Okay, so like NumPy as NP array, and then immutals, which will be useful for image handling, like any kind of basic operations like resizing and like image manipulation. Okay, so immutals can be useful for resizing and that kind of manipulations, and CV2, which is useful for handling the images. Okay, so like reading the frame from the camera, and also like we are going to load the DNN, right? So deep neural network from the computer vision. So we are going to use that. Okay, so that is also going to be important with the help of CV2. Okay, so and then time, which is useful for giving some time delay. Okay, so delay or to take the current time, and those purpose we can use time delay. Okay, so and then it's time to load our pre-trained model. So pre-trained model, in the sense, what is mean by pre-trained model? So the model file which is already present here, right? Cafe model and proto-text file, which two both things which is present here. So what we are going to do, we are going to use that proto-text MobileNet SSD. We have specified the file name. Okay, so we just want to copy the exact name which is present here, and we just want to paste it here. Okay, so proto-text file and model file. So the model file, that is MobileNet SSD deploy cafe model. So that's what here which we have shown here. Okay, so that's what the specified name which is specified for two variables. One is model and another one is proto-text. So this is going to hold down my pre-trained model. So before that, definitely we need to use the cv2.dnn, right? So that here in this two line, we just specified the file name, right? So still now we haven't loaded inside the certain variable. It is not about like a model is equal to, if I specified that file name means I can able to access that file by using the model, not like that. Whenever you are going to import some kind of function which is present in a model file, we need to import by using different techniques. Okay, so here you are using cb2.dnn to load it from the cafe. Okay, so that's what here we did, and this threshold, no, so this threshold will make sure to make sure whether we are getting the better confidence level. Okay, so better accuracy or confidence. Okay, so for example, guys, So if it is a completely empty frame, so I am not here, I just close the camera now. So on the time, definitely on the time, like this confidence threshold will be less than 0.2. Okay, so here we just made some threshold value so that whenever even I'm closing the camera, so even I just close my camera, so it won't look for on the dark part, it won't try to identify that is like a water bottle, that is a person. It won't try to do that. So only it will check, like it will be make suring. So make sure whether it is having or whether it is getting a more than 0.2 accuracy. Okay, 0.2 confidence level. Then only it will try to identify what are the object which is present in that frame. Okay, so I hope you guys are clear up to this lines. Okay, so if you are super clear, you just put I'm super clear in your live chat. Okay, and now it's time to specify the classes. So specifying the classes in the sense, here we are going to use the pre-trained model, which is mobile net SSD, which is already been trained for these object, these specific object. We can't able to change it. Okay, so background. Okay, so background definitely, guys. Another main thing. So we need to train it for background also, because if you are not including the background class, okay, whenever I'm just talking about your upcoming session or something like that, upcoming your program experience, please don't train without the background class. You just capture random images around your room, your table, your black, like white background, black background. So likewise, you just collect random images and you just load it into the background folder. Okay, whenever you are going to work on a deep learning concept, please don't forget to include the background. Else, you will face the problems like whenever you are trained. If let us take an example, guys, you just remove the background class. Okay, you just trained it. Okay, so you just completed your training, and if I'm going to deploy it in application, so if I'm showing in the background, it will try to identify any other classes which is present in the background or not. So simply, so for example, let us take a plain background. So on the plain background, it will try to locate. This is looking like a TV monitor by having like 12% accuracy. It's poor, right? So even there is nothing in there. So if it is trying to identify, it is looking like a TV monitor with 12% accuracy. That is poor accuracy. Even though it will try to do something or it will try to recognize something. So that's why I'm telling you, this is I think it is maybe like fifth tip. Okay, so you just note it down. What is the tip is, whenever you are going for next level deep learning training and those process, please train the background also. So please include the background classes also. Okay, so you just collect different random images and you just load it into the background variable, so that it will be like, it won't be looking for any other object in the background like empty space. Okay, so that's what they also did, like background and aeroplane, bicycle, bird, boat, bottle, bus, car, cat, chair, cow, dining table, dog, horse, motorbike, person, water plant, sheep, sofa, train, TV monitor. So these are all the objects which they have been already trained for. Okay, so now we have the classes. So now here there is a color. So what is meant by colors? Colors is equal to np.random.uniform 0,255 size of length of classes, 3. What it means? I'll show what it means now. Because if you have seen before, guys, if you have closely watched the previous demo, previous output, for me, drawn a bounding box in the color of blue or violet, I forget it. Okay, so if you note down the color, you just put your answers in the live chat. Okay, so you just noted down the color, like that is the blue. It is just drawn a bounding box and it just shown the text in the blue color. And this water bottle is also, that is shown as like in, I think that is a sky blue color. Now it is shown bottle as a brown color and a person as a pink color, right? So let us check with another time, so that we'll check whether the color is changing or not. Now if you are seeing here, person is recognized as the red color and the bottle is recognized as the green color, right? So here each and every time it is dynamically changing its color, right? So that's the meaning of this line. Okay, so I hope you guys are clear up to now. Yeah, Sai Kumar answer is blue. Yeah, exactly, that is a blue, right? So yeah, so here this is the exact meaning of this line. So randomly it is going to get the color. So whenever a new classes is getting introduced, it is going to apply the random new colors. Okay, so blue, black, purple. Okay, so it's really great. So That's the meaning of to here. Okay, so I hope you guys are clear up to now. Now it's time to load our model. Okay, so for loading a model, we have two files. One is proto-text file and another one is model files, right? So we're going to load by using the syntax called cv2.dnn.read from cafe. So this is the syntax which you have learned in this presentation, right? So net is equal to cv2.dnn.read from cafe of proto-text comma model file. Okay, proto-text comma model. So from that we are going to so proto-text. What is the proto-text and the model? So which I've already specified its name, which is going to be this two files. We are going to load that both files into a single variable called net. Okay, by using the syntax called computervision.dnn.read from cafe. So why we are using cafe? Why we can't able to use why we can't able to use readnet from TensorFlow, and why we are not using readnet from Targe, and why we are using now here is readnet from Cafe. Okay, so just for an interaction, you just put your answer like that. Okay, so here we are going to read the net from Cafe. So we just loaded that our model into the single variable called net. Okay, so once it is loaded, so vs is equal to cv2.video capture of 2. So here you can put 0, that is for primary camera here, because in my laptop there is a 3 cameras which is here. Okay, so my inbuilt camera and another camera which is used for live, and additionally I'm using another camera. Okay, so likewise you can able to change each and every time the parameter, and you just check with which argument is matching for you. Okay, so that's it. So up to now, so initialization is completed. So so if you understand up to now, you just put IoT. Okay, so I understand that. Okay, so you just put IoT to show that I understand up to now. So it's just like initialization of variables. Okay, so now it is going. We are going for the functions. Okay, so thank you so much, Mova Chakraborty, that you have posted super clear. So here we have the while loop, that is infinite loop function. So in that infinite loop, that is where what we have written is we are going to read the frame from the camera. So we have already initialized the frame, which is camera, right? So cv2.video capture of 2, which is specified like vs. Okay, so by using the vs.read function, we are going to read the frame from the camera. Okay, so that's what. And after that, so here the time.sleep, which is nothing but simply giving a 2 seconds delay, guys. Okay, that's what this time.sleep is. Okay, and frame is equal to immutable.resize of frame width is equal to 500. So why here with this specified as 500? Because you may ask, so in cafe model, you are told that that is up to 300 cross 300. By here, why are specified with this equal to 500? This is just for an frame which is going to be displayed in the output, because whenever we are running the code, there is one figure which is appearing there, right? So that figure, so that's the size which is specified here. That's why the frame variable, same, the frame is equal to immutable.resize function to display it in a width of 500. Okay, so and after that, so we are going to get the height and then width of the frame. Okay, so height and then width of the frame, like frame dot shape of :2. So it is going to get the two return values, that is one is height and another one is width. Okay, so now it is time to do the pre-processing. So these are like underlies under the pre-processing methods. Okay, so in this pre-processing method, so first of all you have imported IM resize. Okay, so IM resize is equal to cv2.resize of frame comma 300 comma 300. Okay, so with the help of that, we have done a first pre-processing method, because for our ImageNet model there is a two pre-processing need to be done for image. Okay, so first one is what? First one is like resizing. Okay, image size, and second one is the color format. Okay, so some model it may be like grayscale image. So for some model it may be like blob image. So for here we need to convert a blob image. So first of all, the first pre-processing technique, that is like resizing. So resizing is done. Okay. So and then Zainul Abdi, matter is more important than attendance. It's exactly the thing which I need to tell. That's right. So please don't focus on the attendance, guys. Okay. So thank you so much anyway. So and then blob image. So the first pre-processing is done, and second pre-processing is we are going to convert a normal image into a blobbed image, as we have already discussed before, right? This is the syntax which I already learned from the presentation, right? So the scaling factor and by size. So we are going to convert that normal image into a color image. That color which is like a blobbed image. Okay. So by using the cv2.dnn.blob from image syntax, we are going to use the same resize. Here, I'm not using this frame image. I'm just using IM resize, the resize image. Okay, to apply that blob format. Okay, so that's what up to here. Okay, so I hope you guys are clear up to now. We have read the frame from the camera and we just resized into the 500 width to display it in the output, and we just get it shaped like height and then width, like in the two different variables like h and then w, and we just applied a first pre-processing need to be done, that is a resizing of the frame which is read from the camera, that is 300 300. Why we are using a 300 300 is our model which is having the prerequisites that input image should be in the size of 300 cross 300, and second pre-processing is also should be done. That pre-processing is nothing but the frame should be in the color format like a blobbed image. So, okay, so up to now that pre-processing is also completed. Now it's time to set as an input. Okay, so like we know, right? So input layer, hidden layers, and then output layer. Now it's time to we have already did the pre-processing, like resizing is also done, and blob conversion is also done. Now we are going to place that like pre-processed image as an input. Okay, so with the help of like net.set input, we have dropped this blob as an input here. Okay, so that's what we up to now here we did. And detection is equal to net.forward. Okay, so net.forward. So what is the function of forward, guys? So in this session, I've specified three main parameters it is going to return. My forward function. What are those? So those, let us see who is answering first, because it's a really noticeable question, noticeable like answer, because this what I have told about this concept like twice time. Okay, so I have told about this concept like twice. Okay, so what are all the three main parameters this net.forward function, that forward what it will return? Okay, so that's my question is. Okay, so you just put your answers in the live chat. Okay, so yeah, so here we are going to use the net.forward function to start. You can talk it like, you can call it like classification. Okay, classification part. So we are going to start doing our classification. Okay, so from that we are going to detect the shape. Okay, so shape of our detection. So detection in the sense, so first of all we are going to detect from that shape. So from that only we are going to get the coordinates, like what is the coordinate in the sense like that confidence level. Okay, so from that we are going to get the confidence level, whether there is any object which is already been trained for. Is there any object or not? Okay, so the first answer by Bakula Rani ma'am, that is ID, accuracy, and then bounding box. It's really great, ma'am. Thank you so much, Bakula Rani ma'am. So definitely I'll send the code to you, ma'am. You just ping your mail ID so that so you just ping your mail ID on any like any Telegram or something like that. Definitely I'll send you the source code and the data set. Okay. So thank you so much, ma'am, for your response. So yeah, that's what. So detection is equal to net forward. It is going to start doing the training. Okay. So on the training process, here it is going to return as the ID, that is a class ID, and then it is going to return me the that is return me the confidence level, and it is going to return me the bounding box coordinates. Okay, so that's the exact answer which I have expected. And additionally we have Hari Prasad who told the answer, and Arun who told the answer. That's really great, guys, that you all like a lot of interaction here. Forward method is used to move the turtle forward by the value of the argument that it takes. Okay, so yeah, so that's what here which we got, right? So these are the parameters. So what we are going to take, we are going to get its shape, and after that we are going to compare that confidence level. So as I have already told you, this detection variables is going to return me lot of parameter. Okay, so out of this lot of parameter, in the position of 0, 0, I, 2, we will get the confidence level. Okay, so let us I'll do one thing. So I'll print the statement. Okay, so print of, guys, whenever you are can't able to get a certain lines function, you just put a print function so that you'll identify, you'll understand that. Okay, so let us imagine, so in this current frame, so only I'm here, right? So I'm only the person who is like sitting in front of the camera, so it is going to only recognize me as a person, right? So let us run this program, python space main.py. Okay, so that's what which we did. Okay, so here it is getting some kind of values on this coordinate, right? So here we have So out of that, there are a lot of values. So here we got the valid information, right? So here we have this information. Like these are all like, I think it is a little bit smaller, right? So let us try. Okay, so here these are all the values. Okay, so these are all the values which we got. So like which we got, there are a lot of parameter which is written by using the forward function. Okay, so here we got like 0.00 something and 1.5 and 9.9 and minus 4 point something and my 4 point something and 9.2 and 9.5 9.9. So these are all the values which we got. So out of it, let us compare or let us decode one by one. So let us see here. Confidence is equal to detections of 0, 0, I, 2. Okay, so from the 0, like there is the three, how many positions are there? So 1, 2, 3, 4, 5, 6, 7 values which has been written. So on the 7 values, there is a third value like 0, 0, and then there is a third value, that is the I which is specified here, right? So 0, 0, 0. So this is the like 99.99. So which is nothing but like it is a confidence level. Okay. So from that confidence level, we have already specified the confidence level. Whenever the confidence level, confidence threshold which we have specified is 0.2, right? So here we are getting the output that is 9.9. So it is really a good accuracy. So it just identify that there is some of the object which I know. Okay, now that baby is telling that this object I have already, I think I have that knowledge. So likewise, it will try to identify that. Okay, so it will try to identify that and it is going to get this level. Okay, and then it is going to the next level. Okay, so it is going to the next level and in the here it is going to get the ID. Okay, so like it is represented as a 2, right? So here it is represented as a 1. Okay, it is going to get us the ID. So that is like 1.5. Okay, so likewise it is going to get each and every ID. Okay, so like 0, 0, I, 1. Okay, so from that it will get the ID. Okay, so and then it is going to get the coordinates in the sense 3 to 7. Okay, 0, 1, 2, 3. Okay, 0, 1, 2, 3. So this is the third coordinate. And this is like bounding box coordinate is nothing but it is a like rectangle, right? So rectangle or square, it may be anything. Okay, so on that rectangle it is going to get start x, start y, end x, end y. Point is nothing but there is a 2 dimension, right? X or y. Okay, sorry, x and y. The point is x and then y. So it is going to get start x, start y. There is a 2 point for like not a 2 point, like not 2 coordinate for a single point, and index end y. There will be a like a 2 coordinate for a single point. So from if you got the start x, start y, and then index end y, we can able to draw the bounding box around it. Okay, so that's what here which we have obtained. Boxes equal to detection of 0, 0, I, 3 to 7, and also we got a like array. So with that we can able to get that coordinate like what is the start point and then end point. So we got that. So it is time to draw the bounding box. So before that we are going to convert into like integer, so that it will work on like numbers. Okay, or else it will handle like you will get the error like data type won't match. So that is the string you are trying to draw the rectangle for the string data, so that you will get the some kind of that kind of error. Okay, so here that's why we are going to use like specify like a integer data type. And now it's time to consider a label, guys. Okay, so here the label. So what is the label is here? So label means, so here it is printed like classes of IDX. So what is mean by IDX? So IDX which is represented here, right? So we don't know what is the value of this IDX. Let us put the print and IDX. Okay, so I'm here. So ID of a person. Okay, so let us run the program and we'll observe the output. Okay, so if you are seeing here the IDX, which is like when compared to complete data, so there the value which we have obtaining is that is 15. Okay, so 15 is the value which is obtained now. Okay, so okay, so I missed it. Okay, so the 15 is the ID. Okay, so now let us compare with the classes. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so in the 15th position, what is the text which is present there? That is the person. Okay, so from this complete classes, So first of all, we are going to get the ID by using the forward function. So after finding it, so 15th position, so we get that ID value, that ID, that is the class ID. So now we got the number that is 15. So we'll start from 0, 1, 2, 3, 4, 5 like that. The 15 is representing a person. Okay. So from this classes array which we have initialized here, we are going to get that class name. Either it's a person, dog, or cat, or that class name, and then comma confidence multiples of 100. So what is the confidence? So confidence which we have already get, that is nothing but accuracy. Okay, that will be in the terms of like 0.9, 0.3. So we need to represent in the percentage format. That's why we have multiplied with 100. So we'll get that value in the format of like percentage. Okay, so that we got, and after that it's time to draw the rectangle. Okay, so if you want to draw the rectangle, that can be drawn with the help of cv2.rectangle function. Okay, so cv2.rectangle of, okay, the frame means the frame which is already resized for 500. Start y. So how we got the start x and start y, which we got from this deduction coordinates. Okay, so deductions 3 to 7, we got already start x, start y, end x, and y. So this is the start point. Like this is the, like, for let us imagine. So I'm here. So there is a bounding box we need to draw. So for drawing the bounding box, we already know what is the start point and what is the end point. So start x, start y, end x, and y. So out of it, we need to specify the start coordinate. Okay, so like frame, in which frame we are going to start drawing the rectangle, and this coordinate, this is the start coordinate on the left top side, and this is the end coordinate which is in the right bottom side. Okay, and colors. So in which color? Because here we are going to call like colors of IDX. So for each and every person, it will be randomly initiate one color. Okay, so like it will take, or it will consider like colors of IDX. Colors of IDX means, so colors of 15. So because here IDX is 15, right? So it will substitute IDX in the terms of like 15. So for each and every object, it won't allocate the same color for each and every object. So it is going to allocate different colors. Okay, so that's what here which is specified. Okay, so that's what the color which is present specified here. Okay, so the classes which is present here. Okay, so out of it, and comma 2. So what is meant by the comma 2 is the thickness of the rectangle. Okay, whenever you are seeing that output, so the thickness of the rectangle. So that's what here which we did. So up to now we just drawn a rectangle. Now what is the time which we need to do? Because if you are seeing the output, you just tell me what is the remaining thing we need to do. Okay, so we just drawn the rectangle. So you just see the output, guys. So on the output, we just drawn the rectangle. So only one thing remaining on that output frame. What is it? Okay, just put your answers in the live chat. Okay, so here we have drawn this like cv2.rectangle. Okay, so and someone is asking about this this square basis. This is nothing but it is going to consider like float point. Okay, so on the C programming, you'll use to write a percentage d comma ampersand a, right? So a is equal to 5. A scan of double quotes percentage percentage d and like double quotes and comma ampersand a. So likewise you will represent like same as like in this kind of variable, you can specify like first so this is empty, right? So instead of in this place, here we are going to print our name. Okay, and in this place it is a like float variable. In this place we are going to print our confidence level. Okay, that's what here we are going to do. Okay, so that's what. And yeah, the first answer by not getting answer. Menaka, yeah, that's the exact answer. That is nothing. That is not only like displaying and those things. It is time to display the text, because if you are clearly what's the output. So we are just drawn the bounding box. Till now, in the label variable, now we have the text. Text in the sense, is that a person or cat or something like that with its accuracy, like 95%. That accuracy which is already placed in the label. But still now, we didn't write that text in that image, right? So that's the remaining part. So if start text, so here we are going to get this coordinate. So what is this coordinate is? So in this output window, so on that bounding box, so below in which coordinate? So for example, on that blue color bounding box, the person is located little bit below of the bounding box, right? So that's what the coordinate which is being specified here. Okay, so if it is greater than that value, so then it will be printed like above, or else it will be like looking like below. Okay, so that's the purpose of using that. And cv2.put text. So here with the help of that cv2.put text, we are going to display put the text on that frame. So cv2.putText of frame and then label. So what is the label? It is going to hold on the text such as